Hi, you probably learned geometric sequences and series at school today and you're a little confused. Don't worry, I'm here to help. Alright, let's cover geometric sequences first. Basically, sequences are a bunch of numbers that progress consistently. It's very similar to the arithmetic sequences, but the only difference is that in arithmetic sequences, the difference is a plus or minus. So like you're adding a number or you're subtracting a number to get the next number in arithmetic sequences. In geometric sequences, the key difference is that it's being multiplied or divided by. And so you can see that you can't just add a consistent number here to get this sequence. So I'll show you what that means with this example later, but let's cover the general formula first. This is what it is. Un is equal to u1 times r to the power of n minus 1. Bunch of random letters. I'll explain them to you. So u1 in this case, similarly to arithmetic sequences, it's the first term. It's the first term of any sequence. Un is the nth term. So as we covered in the last video, n is the order of where the number is. So u1 would be the first term, u2 would be the second term, so on and so forth. That's what n is. The n here and the n here is the same, and n's are only positive integers, and it makes sense. So lastly, r is the common is the common ratio, right? So before in the arithmetic sequences, it was the common difference. Now it's the common ratio, and that's just the way it's called. It's basically the number that's being multiplied or divided by. And then n minus 1 makes sense. This is just kind of when you need to plug in numbers to get a certain form. So don't worry about it too much. I guess focus on understanding what sequences are. Let's try it in this example. So this is a geometric sequence. It's an example of a geometric sequence, and the way you can tell is that the difference between each term is something that's being multiplied. So u1 is the first term, right? So obviously that would be 1, so we'll write u1 as 1. R is the common ratio, and so if you're a little confused as to how you can find r, in arithmetic sequences it was a little simpler and a little easier to understand, but common ratios might be a little harder to wrap your head around. But if you want to find it, it's basically un over un minus 1, and that just means you can take any number in the sequence and divide it by the number right before it. So let's try it. 1 over 16. I'm picking a big number just to show you that it works with any number in the sequence, not just the first and the second. Divided by the number right before it, minus 1 over 8. So if we do that, that becomes minus 8 over 16. And if we simplify that, it becomes minus 1 over 2. And so r is minus 1 over 2. And if you're not convinced, you can check it for different numbers and it'll make sense. So now we know u1 and r, and so we can write this sequence in the general form. So it goes 1 times minus 1 over 2 to the power of n minus 1. And since 1 is just 1, you don't have to write 1. It becomes that as the final form. Oops. Yeah. So geometric sequences, the only difference between arithmetic and geometric is that it's being multiplied instead of added. Alright, let's look at series. It's the same thing as arithmetic series. It's basically the addition, or it's the sum of all the different numbers in the sequence. And the formula is given by this. It's a little complicated when you look at it, but here's the thing. If you want to remember it, just remember the denominator as r minus 1 or either 1 minus r. And the difference between these two equations is it's the same and it's going to give you the same result. It's just to make calculations a little easier. So if your r, the common ratio, is above 1, is greater than 1, then you use this formula. If your r is less than 1, then you can use this formula. And they're going to give you the same outcome no matter what. And it's just an easier way to calculate, because it's better to have it's better to deal with positive numbers than negative numbers, and you'll kind of see why when you actually apply this to different sequences and series. Honestly, you don't have to remember it. You're given the formula booklet every time, so you can refer back to it. But if you use this often enough, it'll kind of just stick to you. So don't worry about memorizing it. So here we have the same sequence, and we're going to try and apply this to this sequence. So Sn is equal to either this one or this, right? And in this case, we can see that r is less than 1. So we can use r. We can use the second formula. So let's try that. So u1 is just 1 times 1 minus r is negative 1 over 2 times n, right? Over 1 minus negative 1 over 2. And if we simplify that, we should get 1 minus 1 over 2 to the power of n over 1 plus 1 over 2. And you see what I mean when you won't get a negative if you have if you use the right formula. So that should be the general formula. Honestly, it's not very common to see a question like this. You don't have to practice doing this. Just know how to apply the two different formulas in certain situations. So I hope that helped. If you haven't checked out the arithmetic sequences and series video, you can check that out to get a full view of this whole thing. And if you want me to cover a specific topic in math, physics, or chemistry, you can leave it in the comments below. I will try and cover it to the best of my abilities. Although I am a student myself, so if I haven't covered the topic, then I won't be able to do that. But I'll still try my best. Thanks for watching, and I hope that helped. I'll see you guys in the next video.